Hello, and welcome back to Learning with Lee. In today's episode, we are going to discuss exceptions and exception handling. And the reason for that is that I left us off with this problem in the previous episode. And that is, what happens if for whatever reason I cannot dynamic cast I into a weapon reference? In case it were a weapon pointer, it would give me a null pointer back to signify that the conversion failed. Such as if for whatever reason I could make this like a link pointer or something like that. Or for example, in case I forgot to include the asterisk there to dereference it. So I'm trying to convert a pointer into a reference to an object, which isn't going to necessarily work. I have to dereference it in order to convert it to a reference. So how does it then represent that? Because here's the thing, weapon itself, if we head back to our definition over here, it has nothing to store an error or any information about that error. If you want a clearer example, let's consider what happens if you divide by 0. Because the important thing about this happens to be that divide by 0 isn't particularly well defined, and it also depends on how you're doing the divide by 0. Because if, for example, I was using doubles, in case you remember the binary representation that we went over, there happen to be a few different things in there that can actually be used to represent a divide by 0 without having it give us an error. However, if I do something such as in here, c equals a divided by b, where a is 0 and b is 0, or really all that matters is that b is 0. A could be any number. It could be 4, could be a million, doesn't matter. But the thing is that in an integer, in its binary representation, there's no way that I could store that error in there. Because every single value, from its minimum value to its maximum value, could be a valid result from a division. So there's no way for me to get something back in C that tells me that, hey, you messed up and divided by 0. So what ends up happening is that an exception ends up being thrown. And in this case here, it's a divide by 0 exception. In general, what will happen is that in case you do not handle it, your program will crash. And whenever an exception is thrown, it usually should be because there isn't a good, clean way to return an error other than by as an exception. So in this case, you're like in weapon or an item. Neither of those have any information for storing exceptions, and really we don't want to customize every single class to have exception handling information in it. We would rather have separate classes and class structures for handling that. We'll get into creating our own in the next episode. But for now, what really matters is that weapon can't handle this dynamic cast, and there's really nothing dynamic cast knows about whatever type this is here, because it can't have custom logic for every single type of object that gets passed in as this argument in here. As a result, it needs to tell us, hey, you messed up, do something about it to fix it. And that's one of the other reasons why you throw exceptions, is that if for whatever reason within here I had something like this divide by 0, or some other thing that ended up being wrong, what I would need to do is that if it was not something that I could go, okay, I know how to get out of this into a good state, that will work for whatever happens to be calling me no matter where it is in the code, then you can do that. But if you don't know basically whatever your calling code will want you to do in order to make certain that's a valid state, what you then want to end up doing is that you end up wanting it to basically pass that responsibility back to whatever called you. So you want to know whatever ended up calling you that there was a failure at some point. And that's why you use exceptions. To begin with, let's take a look at how you would change this up. Because realistically, we don't honestly need the majority of this. All we really need is this section here. We don't need any of that. And frankly, we're not even going to need any of this in terms of these two here, because these are just going to be fine out on their own. Because if we fail on the ability to convert it into a weapon, well, then we have a few different options, but I'll get into that in a second. So what you do is you use what's known as a try-catch block. So you start off with try and a pair of parentheses to create a scope. And within there you do whatever you're looking to do. In this case here, I could do something such as wkills dynamic cast to the weapon reference. Then, since I have w down here, I can use it out here. So I could do something like catch. And as I said, it's called a try-catch block, and it's called that for a reason. It's because you basically have these two different scopes, right here and here, and the first one's preceded by the keyword try, second one's preceded by the keyword catch. And there is an important thing to consider, and that is that and why it's giving me an error, and that is because up here, I have to specify what type of exceptions I'm looking to catch. This ellipsis right here signifies I want to catch any exceptions that come out of this particular try block here. I could have other try blocks up here. I could also even have a try block within my try block. So I could have something in here that then also catches. It doesn't make as much sense to have it nested that way as it does to say have it nested in this way, in which I have a try catch block in here, in which I might do something else with it and then want to catch that exception. And that happens to be something that you can do. It's a bit uglier, but at the same time, it does make sense in certain situations where you'll want to do that. However, for now, this is the important thing. Basically, we do this dynamic cast. If it fails, we catch it here. And what you're typically going to do in here, and for now, we're not going to focus on the fact that what the specific exception is, but for now, in general, what you're going to end up doing is you're going to want to log whatever error it was. So for now, I'm just going to use cerr, and in general, you'll end up having specific logging software or logging functions with whatever software you're using to write out some file or the like, so as you can basically go back and check whatever problems it had without needing to basically look in a console while it's there, and you don't risk losing that just by closing down your application or closing down the console. So then, whatever you want to describe your error as, and then end your line. Just because you don't want a whole bunch of errors piling up all on a single line, because that would be really hard to read, really ugly to parse. So then what you want to do for describing it, and this is one of those things, is that you could do something such as saying failed cast, or failed to cast. However, that leaves us with a problem. You might end up using dynamic cast and static cast in a whole bunch of different locations throughout your code, and if you use this same error message for every single one of them, it doesn't tell you exactly where you ended up failing. It doesn't tell you that you're in weapon operator equals, or anything else like that. What we can then do is we can go, okay, failed to cast, and I might say something like to weapon, and then do in, and then the name of my method with its appropriate class or namespace. So that basically gives me enough information to pretty much immediately know that my error was in here. So as I don't have to hunt all over for it, and I can just find it pretty much immediately. We can then do what is known as rethrowing. And rethrowing basically signifies that whatever exception we caught, we want to pass that on to whatever called us. Normally, if you don't have a try-catch block here, that exception will keep effectively going up this chain of different functions that called methods, that called functions, and so on and so forth, and it will find the first thing that actually has a catch that expects that type of exception. In case it can't find any, it'll cause your program to crash. So what you can do in case you want to pass it along and do what's known as a rethrow is you just use the throw keyword. And we'll get into the throw keyword a lot in the next couple episodes, but basically this is how you continue to pass along an exception. You can just do this. You can pass along the name of your exception or a class. So now the question is that, do we really want to look at it so as we have that there and this here? Because there's a few different things that we could end up doing here. We don't necessarily need to rethrow it. We could just flat out do this and then perform the item equals here and then return I as before. So what we could do is we could actually just move this into here, because in the event that we left that alone and we had kept this down here without a rethrow in here, it would have ended up trying to assign these using this W that hasn't been assigned to yet because this would have failed. And as a result, it more than likely would have given us a second exception out here that might also have masked the fact that we got this exception, but that could give us additional problems. So to a certain amount of extent, it makes sense to just do this within this try-catch block for the entire thing, in which we don't need that W there, but that is, for the most part, something that you can just do based upon your own personal preference and based upon your own needs, and whichever way happens to produce the cleaner, clearer, more readable, and, in general, whatever ends up generating the output that you care about. Because if for whatever reason you are just going to do the throw in the catch, then you don't necessarily need to have these in there, but you could also just have these in here because it doesn't matter too much if you do. So if you say do this, catches it, and then it can keep processing and do this equals. However, frankly, that probably doesn't make too much sense to do in order to keep assigning it. So let's just toss back in the rethrow. So then the other thing that I had already mentioned was that within this catch, you can specify that you're looking for a specific type of exception. So the specific exception that we're actually looking for in this case is what is known as a standard bad cast exception. And basically this is a class. It's an object. It's similar to weapon, it's similar to item, and we'll get into how we create those in the future. However, there's many different types of these, and you can actually have multiple catch statements. So if I did something such as this within this, and then up here put in an ellipsis, basically what would end up happening is because this ends up catching every single type of exception, it would go through this processing and never go down to here. It only goes into the first one that matches its description. So in general, what you want is you want your most narrow ones and most limited ones up near the top, and your most general ones down at the bottom. So in case you want to guarantee to have some form of processing for any exceptions that you haven't anticipated, you'll want to include this here, and then you might do something along the lines of saying standard error, unknown exception in this operator. So that in general happens to be what you can end up doing in case you want to handle multiple of these, because one of the important things to know is that standard bad cast, in case I did something such as this, in which I caught a standard, and one of the things is just exception, which happens to be, as you could see there from the little C next to it, a class. If I put this here, it's the same thing as, once again, if I had had this here, in that this happens to be the parent of this, and as such, this will end up catching any bad casts without us going down here. So once again, this would need to get moved down, but because it is technically more narrow than the ellipsis case, in which is every form of exception, you want it in here. And one of the other important things to note about these is that you can basically specify a name for them, so you can basically catch and use them. So in case I end up getting this bad cast, and I'll just refer to it as E, and you can just reuse E for basically each one of these within here. But I could do something along the lines of go, okay, I want standard C error, and I want to output E dot, and there's quite a few different things in here, but in general, we're just going to go with what for this. And that should contain basically a general description of what the problem was. And you can put it before or after your other one, doesn't really matter. But it's also a useful thing to output, since this may contain additional information about the particular memory being used. It may contain information about the cast that you were doing from what to what. So that can contain some valuable information. In case we look in here, E also happens to have it. It ends up being what actually defines it, probably as a virtual method or possibly as just a method within E. But for that, it happens to be a different way of handling it. So important to remember that you go from your most narrow to your widest and broadest case, in which it's going to handle the most number of exceptions, because you don't want something like this overriding something like this so as that you don't get your most specific and most appropriate logic for a given exception. So for now, we only care about the bad cast exception. There really shouldn't be any other exceptions that occur in here. What this is currently complaining about is that I'm not catching it by reference, because otherwise I have to pass around a copy of it, and that is a bit uglier than just passing around effectively the same chunk of memory, rather than having to duplicate it at each layer. Lastly, there's one important thing I want you to consider, and that happens to be, what if in here, for whatever reason, I decide to go, okay, I want to create something new. So I'll just call this item I equals, or more accurately, we'll just call this II equals new item, or item pointer II equals new item. Well, what am I going to do if I wind up in this catch here? The problem is that I've allocated this memory on the heap. So I need to be certain that I can actually free this memory and get rid of it so that I don't end up with a memory leak. So here's the problem though. If I try to, within here, let's say, go II or delete II, in which it tries to end up getting rid of that, it's not going to be able to find this. So what I have to do with that is I have to put this up here initially for its declaration, and then do the definition within here, so that then I can still know of that pointer and be able to delete it correctly. So that's an important thing to consider whenever you're creating one of these try-catch blocks, that you want to be certain that you can actually properly do this. So, thank you very much for watching. Have a wonderful day.